So 2 o'clock it comes by, and the site survey task. And the site survey task was to look around at flags, and we had to determine what the GPS coordinate of the flag was based on your location without driving there. So you had to find some way to either do a range finding measurement or to do a matching of two pictures and just to mathematically calculate the distance. We did sort of a combination of the two. We took pictures and then we estimated based on some features and known coordinates where we were. So you can see here, this is our command center as well. While we were actually competing, there was a tent in front, or a cover in front. But big desktop and a couple of laptops. Our communication system is on the side here. And here's a small video of the site survey task. So it's hard to make out. I'll try to point out some flags as we see them. It's a little dark. There's a flag there. There's a flag there. One up there. Again, there's one right there. You can see one in the back there. And so they spread them out over a distance with a background in there so that it's harder to see them. Okay, you can see one there, and one there. So even just from a regular handheld video, it's difficult to see it. So imagine driving around with the Rover, bumping up and down, and using little servo motors to turn the video around. It's quite difficult unless you have a high-resolution system. So we did just that. We took high-resolution pictures of a couple of locations, and then looking at the pictures and the known coordinates, we calculated where the flags were. And so that one we actually did quite well on. We got a perfect score, except we were a little bit late. So they took off a small amount, but nevertheless we did quite well. And it turns out the Canadians dominated that category. The York people also got a perfect score on that one, and then had a small penalty. So this is a small view of our command station. Again, lots of laptops. This is our antenna. We had it mounted nice and high so that it would have as much line of sight access as possible. The more you can ensure line of sight access, the better you can ensure the reliability of your connection. Turns out we didn't lose connection the whole time, which was quite good. And it took one operator to drive around, and then everyone else would sort of look at the video feeds. We were also allowed to have someone walk with the Rover just in case it ran off on you. If you lost communications or something like that, you wouldn't want it to drive off a cliff or drive onto somewhere that might get into trouble and damage some of the equipment. And that's expensive as well. The Rover itself was allowed to be up to $15,000 American. Ours cost around $11,000. So it involved a lot of fundraising, a lot of efforts, a lot of talking with manufacturers to get discounts, and as much as we could for free. So the results. Unfortunately, we didn't hit the top three, but we came not too far off. Oregon from the United States came first, York was second, and Poland third. Now this is the Oregon team here. And the reason I put a picture of that one up is because it was a really cool design. They had 6 tires that could independently change their orientation, which allowed it also to pivot and spin. But it could also do a really neat strafing, which they would demonstrate on the fields a little bit. Now they also had theirs tested so well that they let everyone else come up and you could try it out yourself. So I got a chance to drive the Rover, which was very unique. I mean, ours definitely wasn't to the point of testing and reliability that we could let someone else drive around. But again, it was our first year there, and as we move forward, we've already got a lot of the equipment, we've got a lot of the expertise, and you keep working towards the next year. So we came somewhere around 4th or 5th. They don't release the numbers, but we heard the scores being tabulated, and we're somewhere around there. So even though we weren't able to compete in the first 2 competitions, that's a pretty good score. There were lots of teams that couldn't compete. Everybody had failures. And in fact, because there's only 2 hotels and a campground in Hanksville, 4 or 5 of the other teams were in our hotel. One was next to us, and they were dealing with their code the whole night. We saw them awake all night trying to fix their code. Of course, we were awake all night trying to fix our power issue, so we were in just as bad shape. So again, we got the highest score in the competition for the site survey, so that was a very proud moment for us to actually, once we got in the competition, we did pretty well with what we had. Tuesday, 11 a.m., another 3,500 kilometers later, we drive back. So it was a very short trip. In a matter of 8 days, we drove nearly 8,000 kilometers. So some of the lessons that we learned from dealing with the rover competition, it's a very harsh environment. So even though it's an Earth environment, it's still very dusty, very hot in the middle of the desert. We determined that a lot of our failures were caused by overheating and things. The vibration was a key one as well. Things would vibrate loose, things would overheat, and the dust does some strange things to things as well. Full testing before any competition is key. If you can manage it, you want to make sure that every single piece is tested. Now, the Oregon team that won, they were able to do this because they had competed a couple times before. They had some of the resources, some of the knowledge already, and so for at least a month before the competition, they were out driving every weekend in the desert. They're not too far from Utah, or desert-like conditions as well. It's a little harder for us to test in an environment like that. We don't really have places like that in Ontario or in this part of Ontario. We also learned that Loctite isn't strong enough. So if you're familiar with Loctite, it's a glue that you can put on screws to keep things there pretty much forever under normal circumstances. But everything was under such vibrational loading that the screws worked themselves loose, and we had some things come loose. We had an axle that came off because one of the screws wasn't tight enough as well. So it's just as much as you can in your design as well as in your construction, make things reliable and robust. And if they do come apart, you want them to fail gracefully so that you don't lose a wheel or lose a camera, something like that. One of the other teams had told us the year before, they were driving around, they had 5 cameras on their rover, and after the one competition, one of the cameras was still working and 2 of them had fallen off. So things are very vibrationy as you drive around. And the last lesson that I'll share with you is, again, bring everything you might ever need, as much as possible, because you never know what's going to fail. So this is some of our team here. We've had lots of people involved over the years. One of the things we have to do as engineers for our degree is contribute to a 4th-year project, and that project can be anything you want, and just has to exercise some of your engineering and design skills. And so I did it for my engineering project, as well as there's another guy doing it this year, and there's one last year as well. So we've had a good way to combine it academically as well as volunteer-wise for the project. Some of our sponsors, and this is what somebody was asking about zero gravity. This is the best way on Earth we can simulate it. With an airplane, you jump up and you get microgravity, I guess, for a second there. Some of our sponsors, again, we talked to lots of different companies about helping us out. And if you ever need supplies or anything like that, the best way is to approach those companies and build up your sponsorship base. And lastly, as we like to say in the Mars Society, on to Mars. So with that, I can open it up to any questions that people have. Yep.
What were the documents for in the site survey?
So in the site survey, we ran a little bit over time during our calculations. So I think we were 5 minutes late, and so they took 10 marks off. Out of 100. So, yeah. So it wasn't a huge document, but it was enough to tie us with York, who also got 90 out of 100.
Dr. Mack, would you the most thinking about
Yep.
You said that there were coordinates, GPS coordinates that people had to change somehow to get into a coordinate system that their hardware or software would understand.
Yeah.
Is that a competition aspect to see if you can do that, or is that an accurate representation of something that would be involved in a Mars rover, an actual rover?
I think that's more a competition aspect. Again, so there's no GPS system yet on Mars. Hopefully there will be by the time we get there. But for the competition, they decided to give it to us in a standard. And as students, it's a little trickier to program something that will take in any format that we know ahead of time. But most hardware comes expecting a given format. And if you don't use the format your hardware uses, then you're going to have a pretty rough time. So that you had to do some translation there, and it proved to be more of a challenge than we expected. Just understanding the different systems.
So what percentage of your budget was actually donated?
So we had maybe 30% donated or 40% donated, and then the rest of the money came from, a lot of it comes from campus endowment funds. We have everyone at the school donates a bit of money every year with their tuition, and that money builds up, and then they spend the interest on student teams. So we were able to apply and gain some money from that. We got some money from the Canadian Space Agency, and some money from our Dean of Engineering, a couple of private sponsors as well. But it takes a long time to build that kind of money up. It's not, as I'm sure you guys are aware, it's hard to buy things.
Okay.